Alcohol. So in chemical properties of alcohol, what you have to study. So let's discuss what we have studied earlier that regarding the alkane, alkene, and alkyl halide. So the difference between the alkene, and alkyl halide are the functional groups. So you understand that how the chemical properties behaves in case of alkane RH. So R carbon attached with a hydrogen, and in case of alkyl halide carbon attached with a halogen, right? And in alkene carbon attached with double bond to carbon. So if you see these three things, so you have studied already the chemical properties. So here there what we have studied. So carbon and hydrogen, in case of alkane, to remove the hydrogen you need huge amount of heat and huge amount of energy, right? So that gives the substitution reaction. uh, Next, in case of alkene, we see that due to pi electron it gives the addition reaction, and in case of your alkyl halide there is an electronegative difference Cx. So you are seeing that substitution reaction or elimination reaction is possible. Similar way, if you see the carbon alcohol group COS, so there is a electronegative difference between oxygen, hydrogen, and oxygen and carbon. So you can accept that here you can get some substitution reaction and elimination reaction, right? Okay, so let's study. So you see that you have to read this one, that carbon oxygen of the bonds are polar since oxygen is highly electronegative. So what happen, not the bond may break down from here or the bond may break down from here, right? So you have to think in that way. The bond may be carbon and oxygen, so electronegative difference, so they can't sit together for long run. So if any external reagent, heating or any reagent would be given, so the bond can be broke down from here, and similar here it can be broke down from here, right? So depending on the reagents and condition, this the bond supposed to break down. Okay, so what are the different reactions are possible? In overview, they have given that from alcohol you can prepare alkyl halide. From alcohol we have saw that we have prepared alkene. From alcohol upon oxidation you can get carboxylic acid. From alcohol upon oxidation you can get ketone. Secondary alcohol, if you take the primary alcohol, so upon oxidation it will give the aldehyde. Upon reaction with some other reagents you can get ether. Then upon reaction with carboxylic acid you are going to get the ester. And alkyl halide upon halogenation with PCl3 PCl5 SOCl2 with ROH you can get RX. So what are the different reactions? So basically we have studied in a trend that alcohol, any chemical properties may be your oxidation, reduction, and depending on the nature of the functional group, whether it will give addition reaction, substitution reaction, elimination reaction, or miscellaneous. So the common two things are your oxidation and reduction reaction. Okay, so let's study what others reaction it is going to give. So first of all, reaction with active metals. Okay, so when alcohol will be treated with a metal like sodium, see, sodium is such a reactive that if you will put a football size of sodium in a pond, so it will give a huge blast. If you want to see, you just go to the YouTube and search this one, so you can get this one very nice video how reactive the sodium metal. Okay, so when sodium metal will react with OH group, so he's going to throw out the hydrogen in the form of hydrogen gas, and he'll form the sodium salt, that is sodium alkoxide. Understand, reaction with active metal. So if you take ethyl alcohol in sodium, so it is going to give you the sodium ethoxide. So lot of drug molecules, if you see, so due to their polarity, solubility problem, they supposed to be formed in the sodium salt to enhance the solubility. So in higher classes you are going to learn that how sodium salt of any compound, if it is insoluble, in water, so if you will make it sodium salt, it's going to soluble, because you know that. So sodium chloride is dissolved in water, so any salt is easily dissolved in the water. So this is the sodium salt. Okay, you remember in that way. So what is that? The see here what is when ROH reacts with Na, so it is released to H2. So you can understand that one, that it's forming one kind of ether, that is sodium salt. Okay. It is also totally depend on the whether it is a primary alcohol, secondary alcohol, or tertiary alcohol. So basically, if you remember this basic COH, so if the bond will break down from this OH and it becomes H plus and here O minus. So H plus, if you know what is the definition of acid, acids are the compound as per your Arrhenius and Bronsted theory that those can give H plus. So if this bond is going to break down, so it is going to give H plus. So you see this ROH from here, H plus is removed. So this is also behaving. This alcohol is little acidic. Understand, as the bond is going to break down from here. So the compound those have the tendency to give up H plus by presence of some metal easily, then they can give this kind of reaction. So basically the primary or alcohol are more prone for this. Okay, if you take the tertiary alcohol, so due to the plus I effect, that is your inductive effect, it will be reduced. Understand, it is going to reduce up due to the plus I effect. So you always remember that tertiary alcohol is, so you may ask, sir, how, what is that plus I effect mean one kind of electron releasing group, electron donating group. See this, if you remember R matlab it's CH3 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 CH3, 3 CH3 are there, so they do have the sigma electron, they're supposed to give the electron to this. So see, O and H already have a huge amount of difference in the electronegativity. If you are providing electron to the system, so what is happening, the OH electronegativity is going to decrease. You understand, no? So as a result, no, it is not going to break down the bond easily. So due to this, so if you put some I minus group here, no, so it can give out H plus very faster. So if you the I minus would be there, so the reaction would be much more faster. Understand? So you have to remember that one, that primary alcohol is more prone to the sodium salt formation compared to tertiary alcohol. Okay, so you, and see here, alcohols are not acidic enough to react with aqueous NaOH and KOH. Okay, so this thing, if you will take a aliphatic alcohol, no? Aliphatic alcohol, I'm talking regarding the aliphatic alcohol, they are not going to react with sodium hydroxide, so they are supposed to react with the aromatic alcohol only. So you always remember this one. Okay. So this is one example that how the reaction is occurring in the bubble, and this methyl alcohol is used for the excellent fuel for the car due to the some different properties. So this is the use of alcohol, you may remember that one. So next is your halogenation. You may remember like that reaction with phosphorus halide. So PCl3 PCl5, if you remember, in case of your preparation of alkyl halide, so if you are taking alcohol and doing the halogenation reaction like PCl3 PCl5, you ends up with alkyl halide preparation. So it's easier that you can remember ROH when reacts with your PCl3 PCl5 or PBr3 PBr5, you are going to form an alkyl halide. Okay, so this is one. Same way reaction with thionyl chloride SOCl2, it is also again from, these are the sources of halogens, you always remember, Cl2 PCl3 PCl5 SOCl2. So this supplies the your halogen group to the system. So you always remember that if the more is there, so HCl would be removed or HX would be removed and the X would be one added here, ROH, so it's going to form the RX. Okay, you always remember that one. Next with your reaction with hydrogen halide, again every source of halogens if you are going to treat, so you are going to end up with alkyl halide. You always remember this is nothing but one kind of halogenation reaction seen in alcohol. How you are going to prepare alkyl halide from the alcohol, that is very easier, you have already studied, right? So next, see how the mechanism goes. So see that oxygen is having lone pair, so when you are treating with, see one more thing, that HX HB HX, they are supposed to be acidic because H plus X minus. So you know the definition of acid who can gives up H plus. So when they will hydrolyze, they are going to give H plus and X minus. That's why they are little acidic in nature. When alcohol you will go and treat with HX and any kind of compound HBr. So what happened now, H positive will going to attract by the lone pair of the oxygen. See, so it's going to attract and it's form a water now. It's now a bulky group, so it can lift out very easily. So what happened, this group, once the Br minus will going to attack, so it will going to lift out very easily. So it's going to be SN2 reaction. No, you are seeing no, पीछे से आके attack कर रहा है. So it gives the CH3 CH2 Br, and this is a primary alcohol you are seeing, right? Okay, so next is your nitration reaction. Okay, so you always remember that if you do the nitration with the reaction with nitric acid, so this kind of nitration you always remember. Okay, so this is nothing but treatment with nitric acid. If you treat the alcohol with concentrated nitric acid, so it gives up ethyl nitrate. ओके, इथाइल अल्कोहल लिया तो इथाइल नाइट्रेट, मिथाइल अल्कोहल लिया तो मिथाइल नाइट्रेट, प्रोपाइल अल्कोहल प्रोपाइल नाइट्रेट. So it's very easier to remember for your exam point of view. So reaction with sulfuric acid, so sulfonation, you see hydrogen sulfonation. So what is happening with here, so water is removing at room temperature concentrated H2SO4, so it's giving ethyl hydrogen sulfate. Okay, C2H5O SO3H. So this is one nitration, sulfonation. Okay, you have some miscellaneous reaction you have studied. Then dehydration of alcohol. So we have already studied in alkene preparation that upon heating, so this see you are giving the heating reaction, mean this is an E1 reaction. No, so this is unimolecular elimination reaction. You are going to form alkene, ethene. So from alcohol also upon heating you are going to get ethylene, alkene. So you can prepare from alcohol to alkene in this mechanism. So mechanism you have already discussed. So let's see here the mechanism how it is forming. So H plus you are seeing. So it's forming the E1 mean carbocation has to be there. So carbocation has been formed. So after once carbocation, it has to be stabilized carbocation. How carbocation, the hydrogen to the antiplanar region is going to remove and it's going to form this kind of thing. Okay, ethylene. So you know this carbocation formation mean tertiary is always stable compared to secondary and primary. Okay, see same example is there. So it's totally depend on one more rule we have studied in alkyl halide, that Schaeffer rule. Which one is going to see here, only two carbons are there, it is at the end, so there is no choice. But if a carbon is having in the secondary position is there alcohol, so there is a choice that alkene can form this side or this side. Okay, this left side or right side. So it's totally depend on the stability of carbocation. So which carbocation is more stable. Okay, so you have to see in that way that which carbocation is more stable. So upon this, so this would be the major product. You have already discussed this, I am not discussing this again. So dehydration of alcohol to ether. Okay, so what is happening now, if you will take alcohol in excess and you are going to put some acid and heat, so what is happening now, they are going to condense each other and dehydration, water molecule is going to remove. So two alcohol is going to condense each other and dehydration would be occur. So as a result ether is going to form. So how it's happening, see this protonation alcohol upon treatment with acids. So always remember, whenever you are adding up any proton source to the alcohol, no, automatically this proton would be attracted by the electron present in the oxygen. So these electrons are negatively charged, so they have been attracted to the hydrogen easily. So now it's forming a bulky group. So this bulky group upon heat, little heat, it's going to remove out, so it form a carbocation. You see, so the carbocation is there, so one more alcohol from there, the lone pair of electron that is negatively charged is going to attack to this carbocation and this form oxonium ion. So oxonium ion is not stable, so to make it stable, so upon inside it's going to rearrange itself and this hydrogen is going to remove out. So this hydrogen is removed out and form a ether, diethyl ether. This is the mechanism how it occurs, right? One more thing that, so how it is forming, let's see that alcohol upon condensation with acid and heat, it's giving you what? ether. You always remember. Okay, next comes your, if you are going to heat alcohol upon aluminum oxide, so aluminum oxide, if the catalyst is there and if you are heating less than 200 degree, so it give me ether. But if you are heating greater than 350 degree, no, 350, 400, 500, so it's giving the alkene. So in alkene preparation you have studied this one, I think. Okay, how you have prepared the alkene, so you can remember this one. Reaction with carboxylic acid, alcohol and acid, when they supposed to react each other, so they form a ester. That's a common thing, you know it from class 10, 12, so you don't have to bother regarding that. So this is one easiest reaction you can remember. Again, same way, acid halide and acid anhydride, RCOCl, so HCl would be removed, again it form a ester, right? Then acetic anhydride, from here acetic acid would be removed and it's form a what, ester. Okay, so this is the way. Next is your you study that Gignan reagent, how upon reaction with alcohol with Gignan reagent, what is the product. So in alkane preparation you have already studied that al- alcohol upon treatment with Gignan reagent, it is going to form an alkane. Okay, so it's very easy, you can remember this. So reduction reaction upon alcohol, so like your RX alkyl halide upon reduction, what you are supposed to get, alkane. Similar way, alcohol upon reduction you are going to see, mean reduction is nothing but removal of oxygen or addition of hydrogen. So here removal of oxygen occurring, so RH is there. So very easier, you can, alkyl halide also same way behaves in that way, right? RX upon heating with metal or whatever the condition, it gives RH, right? HX would be removed out. We have studied oxidation mean nothing, addition of oxygen, so CH3 CH2OH or removal of hydrogen, we know this one, right? So oxidizing agents, what is KMNO4 H2SO4 or sodium perchromate with chromic acid with your H2SO4, what is happening now, depending on the types of alcohol. So upon oxidation, whether it is forming a aldehyde or ketone, primary alcohol supposed to give aldehyde, secondary alcohol if you take it is going to give the ketone. Okay, so in this case, if you see the how the strength of oxidizing agent, it's most important. If you are taking a much more strong oxidizing agent or huge concentration is there, so this alcohol directly convert to carboxylic acid. Or if it is less oxid strong, less lower oxidizing agent, mean less reactive oxidizing agent is there, so it is going to give you the aldehyde only. Okay, so you remember this one. So the secondary alcohol upon oxidation is give ketone. Okay, tertiary alcohol, if you are going to react with sodium chromate, so it is not going to give you the any reaction, no reaction. So you must remember the difference if someone will ask you how are you going to differentiate between the primary alcohol, secondary and tertiary alcohol, so this is a particular test for alcohol, oxidation test. So primary alcohol will gives you the aldehyde, secondary alcohol will give you the ketone, and tertiary alcohol no reaction is there. Okay, but and upon huge amount of heat and drastic condition it can give you the reaction. So this is also one heating reaction with hot copper. If you are going to do, again this is one dehydrogenation reaction occur. This is also one kind of oxidation using the metal. Upon heating, what is happening now, removal of hydrogen is occurring. So alcohol upon heating with copper, so it gives you the aldehyde. Okay, so this you please remember. So this is the chemical properties of your alcohol. So what we have studied, just revise for 2 minutes, that we have studied that alcohol. Let's see this chart. So you must remember this chart. So once you see this chart, you must able to write down this. So alcohol upon treatment with what you are going to give, alkyl halide, how you have synthesized PCl3 PCl5 SOCl2 HX, whatever you are going to add the reagents, you are going to give alkyl halide. So alkyl halide, sorry, again alcohol, when you are treating with acid, carboxylic acid, what you are going to get, no, you are going to get ester. Okay, you are going to get ester. Okay, again same way, if you treat alcohol with alkyl halide, sorry, if you treat with alcohol with acid chloride or acid anhydride, so again you are going to get the ester. So alcohol, if you oxidize, what is the reaction? you may get the carboxylic acid. If it is a strong oxidizing agent, alcohol upon heating with E1 reaction in presence of H2SO4, you are going to get alkene. Same way, the secondary alcohol, if you are going to put some oxidizing agent like K2Cr2O7 or KMnO4 in presence of acid, so you are going to get secondary. The secondary alcohol gives the ketone, and the primary alcohol, if you take and the same reagent, it's going to give you the aldehyde. And how you have started prepare the ether alcohol you have taken, and you are putting it the sodium metal, so it gives you the sodium salt, that is your sodium alkoxide. Again, in case of ROR dash, how you have prepared, let's see. Okay, so you see dehydration of, so concentrated H2SO4 when you are providing, so it's giving the ether. So alcohol upon heat with presence of acid only, it gives you the ether. Okay, so you remember that chart and try to remember the chart only, so you can remember easily. So next my lecture, I'll write up in a very short form that how you can remember this reaction very easily. So I think that I make you understand by this video. So please, and this you remember the treatment of hot copper dehydrogenation, it's give the aldehyde. So this would be enough for you. So please write a question for this, that what could be the what someone maybe ask you in the exam, that for 5 mark question, that write a short note on the chemical properties of alcohol. Okay, so in 2 mark question someone may ask you that how could you differentiate between primary, secondary and tertiary alcohol. Okay, and upon treatment with nitric acid, what is the product? Upon treatment with sulfuric acid, what can be the product of alcohol? So we have left this nitration reaction, sulfonation reaction of alcohol also in revision. So this is very easy, I believe you can easily. And oxidation reaction, reduction reaction, it's very easy. Reduction mean removal of ऑक्सीजन, यू रिमेम्बर, तो रिमूवल ऑफ ऑक्सीजन, ये चीज आपको याद रखना है कि ऑक्सीडेशन मतलब क्या, रिडक्शन मतलब क्या. रिडक्शन कर रहे हो मतलब रिमूवल ऑफ ऑक्सीजन और रिमूवल ऑफ हाइड्रोजन. सो यू मे ट्राई बाय योरसेल्फ द रिडक्शन करना है मुझको अल्कोहल का, तो क्या होगा. सो यू कैन सी द रिडक्शन प्रीडोमिनेटली एडिशन ऑफ हाइड्रोजन, और यहाँ से हाइड्रोजन तो निकलना नहीं है, एडिशन ऑफ हाइड्रोजन करना है. एडिशन ऑफ हाइड्रोजन करने से कुछ हो रहा है, यू कांट सी दैट एनीथिंग इज हैपनिंग. सो another definition is removal of oxygen. So remove this oxygen, no, once it can be removed, so you are going to get the alkane, no. So easy. Oxidation mean you see what is happening, no, addition of oxygen or removal of hydrogen. So what is happening here, removal of hydrogen is occur. Once the removal is there, then it is forming the aldehyde. So same way here in this oxidation, addition of oxygen is there, aldehyde upon oxidation, what is there, carboxylic acid is prepared. So this is in brief the, or someone may ask you write down the 5 chemical properties of alcohol. In this way question may be asked you for your midterm or final exam. So be prepared for this, and I'll provide you the I have already sent in your module regarding this subject. So please have a look on the module that this part is there or not. This note is already provided you, so prepare your notes as per the graph how it has been mentioned. So I'll write a paper what are the important reactions are there, and I will provide in the note also, okay, in the WhatsApp group also. So please read this for questions. So remember, best of luck. So next class I'll discuss you the test for alcohol what I have teach you. So again you will study the further the application part, uses, structure and uses of different compound. Already we have discussed regarding the preparation of alcohol. So I'll prepare this video for you, and I'll upload in the YouTube. Please have a okay, thank you.